So next topic in our stoichiometry, redox reaction by transfer of electrons. So already we know that one redox is nothing but involving of oxidation and reduction is called as redox reaction. So I want to explain here the redox reaction by transferring of electrons. For example, I am taking here 2 moles of sodium and reacts with here the 1 mole of chlorine will give what is the product here, 2 moles of sodium chloride. Okay, in this one sodium atom, okay, loses how many electrons? 2 electrons. By each sodium 1 electron, so 2 sodium atoms will loses 2 electrons. Next one chlorine. Okay, in this one chlorine gains 2 electrons. Okay, so it is the redox reaction by undergoing the transferring of electrons. From here the sodium loses the 2 electrons and form 2 Na plus. Next of all chlorine gains the 2 electrons, forms here the 2 Cl minus. Okay, so next topic here, competitive transfer of electrons in redox reactions. Okay, next topic, competitive transfer of electrons in redox reaction. That means, for example, this one, especially this topic is used for the preparation of galvanic cell. Preparation of which one here? The galvanic cell. Okay, in the galvanic cell always which type of the reactions takes place? Redox reactions takes place. Okay, so in this one I am taking galvanic cell. These are including which one here? The redox reactions. So I will explain with one example. Just of all, I am taking here the zinc rod. Okay, it should be put in the copper nitrate solution. In the copper nitrate solution, what is the oxidation state of copper here? Cu plus 2. So that's why you can take here the Cu plus 2. Okay, it is our zinc rod. It should be put in the copper sulfate or copper nitrate solution. So in that situation, okay, so zinc should be loses its 2 electrons. That means it is involved in the oxidation, and copper should gain those 2 electrons and forms here the copper. That means upon the zinc rod, copper plus 2 ions are occupies. Okay, in that situation copper plus 2 is converting as here the Cu, and zinc should be converting as here the Zn plus 2. Okay, so it should be occurred by experimental process. Okay, now whenever you are taking here the copper rod, okay, which one here? The copper rod. If you have to put in the zinc sulfate solution. In that situation we should not form here the copper ions. We should not form here the copper ions due to the reason here there is no comfortable reactant for the formation of the products. So that's why there should be copper remains Cu plus 2. Okay, and as well as here the Zn remains here the as it is. Okay, but if silver rod is, okay, which one here? The silver rod is, sorry, not silver rodding, I am taking in the silver solution, either silver chloride or silver nitrate or silver sulfate. So those kind of this one. Okay, actually silver does not possess the plus 2 oxidation state. You can also write here the 2Ag plus. That means I am taking how many silver ions here? The 2 silver ions containing solution. In that solution I want to put here the copper rod. I want to put here the copper rod. Now these silver ions may occupy on the rod of copper. So in that situation copper should be converting into here the Cu plus 2, and 2Ag plus is converting as here the as silver layer upon the copper rod. That means, so whenever you are comparing here the, in this one which one is loses the electron? Zinc. In this one which one is the loses the electron? Copper. That means if you want to give the priority order of losing of electrons, which one is the first one here? The zinc, and is always greater than copper. Okay, and is always greater than here the silver. That means in these 3 ions, which one easily loses the electrons? Zinc. That means which one easily oxidizes here? The zinc. So depending upon this one, there should be preparation of electrochemical series. Which series here? The electrochemical series takes place. Okay, depending upon the electrochemical series, the galvanic cells electrolysis processes involves. Okay, electrochemical series is prepared by the competitive transfer of electrons in redox reaction. It is also redox reaction. It is also redox reaction. But whenever the zinc, copper, silver, not only these three metals, whenever you are taking remaining metals which can used as the electrodes in the electrolysis. Okay, those electrode series also given by which one here? The electrochemical series. That series is used for the purpose of galvanic cell preparation. Okay, so it is the important information about the redox reaction by transferring of electrons, competitive transfer of electrons in redox reaction. Next, one more topic. Already I introduced this one. It is nothing but oxidation number. What it is here? The oxidation number. Okay, so oxidation number I already given the definition. It is nothing but the charge on ion is called as oxidation number. Okay, the charge may be here the positive or neutral or negative. Okay, so in our modern periodic table we have different types of the elements. For example, first one, what it is here? The hydrogen. Normally hydrogen can show, so what is the oxidation number here? The +1. Due to the reason it has one electron in the valence shell, always it want to lose that electron and it shows here the +1 oxidation state. Okay, for example, I want to give first A group elements. First A group elements is nothing but alkali metals or alkali earth metals, alkali metals. So for that one is nothing but sodium, okay, potassium, cesium. These can also show which oxidation state here? The +1. Alkali earth metals is nothing but what are here? The magnesium, calcium. Those can also show here the +2 oxidation state. In the third group, which element is present here? The aluminium, boron or aluminium. So generally it can show which type of the oxidation state? +3. Okay, next of all I am taking here the halogens. Halogens are nothing but fluorine, chlorine, bromine, iodine. Okay, those are always shows here the which type of the oxidation state? -1 oxidation state. Okay, and oxygen. Okay, oxygen generally shows which type of the oxidation state here? The -2. Okay, it is general oxidation number of oxygen, but in some cases oxygen can also shows -1 oxidation state. Which one here? The -1 oxidation state. So -1 oxidation state is possible for which one here? The peroxides. For which one? Peroxides. Of course, oxygen may also show here the -1/2. That should be present in the superoxides. That should be present in here the superoxides. Okay. So next of all, I want to give one more information about the oxidation number. So generally, so here I discussed about the oxygen oxidation number. Now, our hydrogen. Generally, our hydrogen can show here the which type of the oxidation state? +1. But whenever hydrogen combines with metals, combines with which one here? The metals. Okay, so in that situation hydrogen can show here the -1 oxidation state. Okay, generally hydrogen can show which type of the oxidation state here? The +1. So whenever the hydrogen combines with the metals, in that situation hydrogen can always show here the -1. Okay, due to the reasons metals having here the highly electropositive character. So that's why metals can show the positive character or positive oxidation number. Remaining negative oxidation number is suitable for the hydrogen. Okay, these are the general principle or general oxidation numbers of some elements. Okay, now I want to explain with the example. Okay, for example, I am taking here the well-known compound potassium paramanganate. Which one here? The potassium paramanganate. In the potassium paramanganate, I want to calculate the manganese oxidation number. Which oxidation number here? Manganese oxidation number. So for that purpose, I am taking here the K. How many potassium atoms here? The 1. So manganese also 1 plus number of oxygen atoms are here 4 into oxygens. So is equal to, is there any charge upon the KMnO4? No, so that's why you have to put here the 0. So potassium belongs to which group element? First group element. Always shows here the +1 oxidation state. So in the place of potassium you have to put here the +1. So we have to calculate the manganese. In the place of manganese you can use X. Next of all 4. Okay, oxygens generally oxidation state what it is here, the -2. So 4 into -2 is equal to here the 0. So that means here you can write 1 plus x plus into minus minus 4 to 8 is equal to 0. That means x minus 7 is equal to 0. X is equal to how much here, the +7. That means manganese oxidation number in this compound is here the +7. Okay, if you take the second example, potassium dichromate. Which one here, the potassium dichromate. So in the potassium dichromate you have to calculate the oxidation number of chromium. Okay, for that one you have to take here the how many potassium atoms? 2 potassium atoms, plus how many chromium atoms? 2 chromium atoms, and as well as here the how many oxygen atoms? 7 oxygen atoms. Okay, is there any charge upon this substance? No. So is equal to, you have to take here the 0. So for the potassium what is the oxidation state? +1. 2 into +1 plus I can give here the 2x, and 7 into -2 is equal to 0. So from this one 2x 14 is equal to 0. So now you can write 2x minus 12 is equal to 0. So 2x is equal to 12. So x is equal to how much here, the 6. Okay, each one of the chromium can shows what is the oxidation number here, +6 oxidation number. Okay, if you take the one more example, so general example, hydrogen, what is the formula here? I can take N2H4. Okay, so for this one you have to calculate the oxidation number for hydrogen. Okay, so in this one you can write what it will be, 2 into N plus 4 into hydrogens is equal to 0. So 2x plus 4 is equal to 0. So you can write here the 2x is equal to -4, x is equal to here the -2. That means each of the nitrogen atom can shows what is the oxidation number here, the -2 oxidation number. Okay, so these are general calculation purpose of the oxidation number.